Hello everyone, welcome to Infra Experts. This is the second session on Terraform on AWS. So what all things have we learned till now? The Terraform Fundamentals, the commands language, settings, providers, resources, variables, data sources, meta arguments. So the basic things we have learned till now. In this section, we will be concentrating on the fundamental blocks. Till now we have seen how to create an EC2 instance. So in this block, we will be seeing the theoretical part as well as we will be seeing on how to generate a EC2 instance and create a website, static website out of it. So in here, we will be concentrating on three basic fundamental blocks which are Terraform block, provider block and resource block. So these are the three blocks in which we will be concentrating. The Terraform block and provider block will be declared. Here we will be using two Terraform configuration files. One is settingsblock.tf and the other one is resourcecreate.tf. Okay. And in this Terraform, the Terraform block and provider block will be declared under the settingsblock.tf. This will be used in whole course duration. Whereas any resource which we are going to define will be defined under resource-create.tf configuration file. So Terraform block, this earlier before 0.14 version, we did not have this Terraform block. From 0.14 version onwards, this block has been introduced. This is a special block used to configure some behaviors in the Terraform. So something like what is the required Terraform version we are supposed to use? What all the list of required providers for your respective applications? Whatever the infrastructure we are planning to provision. The Terraform backend information can also be provided in this Terraform settings block. So this is the backend information. This block can be called in three ways: Terraform block, Terraform settings block and Terraform configurations block. So whatever we call, it's the same. Each Terraform block can contain number of settings related to Terraform's behavior. Within it, this is very important to remember. Within a Terraform block, only constant value can be used. Arguments may not refer to named objects such as resources, input variables, etc. and may not use any of the Terraform language built-in function. So in Terraform blocks, we will be only using constant value. The first thing we are going to define is the Terraform version as given in this example. In addition to that, you need to define the required providers. Like in here, we are giving AWS, or you can give a Azure, Google, or any other random providers. Next thing is the Terraform backends. Every Terraform project will have its state information, which you can call as terraform.tf state file, or the Terraform configuration information which is stored inside that file, which is nothing but the live environment. Whatever you have provisioned using Terraform, that information will be stored in the terraform.tf state file. And that file, where it need to be located, will be defined using the Terraform backend. So if you don't define that backend block, it will be stored in your local working directory in the root module working directory. We will learn more about it in our upcoming sessions. So in this example, we are keeping the Terraform backend file, the TF state, in this location, in this bucket, in my S3 bucket. So let's create a Terraform block which is nothing but the settings block first. So let us go to our Visual Code editor. So here we are. Now in here, let me create a file and let me give the name as YouTube. And so in YouTube, let me create the settingsblock.tf. Settingsblock.tf. So this is the Terraform configuration file. And in here, the first thing, let me give this Terraform block. Let me just hash it out. Let me give this as comment. And in the Terraform, let me take this. Let me give the required version in here. So in here, I can give the required version as 1.0.11 because if you go to your command prompt and just write here Terraform version, you can see 1.0.11 is there. And now in here, if I give tilde, then greater than sign. So this is the version constant concept of Terraform, which we will see in the latter phase of the course. This means any changes to the rightmost, means this one version happens, which means it will allow the versions like 1.0.12, 1.0.13 and so on, but it won't be allowing 1.1.11 or 1.2.11 or whatever. So the rightmost version update is only allowed in here. Now if you remove 11 from here, if you remove this 11, it will allow 1.0.xx as well as 1.1.xx, but it will deny 2.x.xx. With that said, we have defined the required version of Terraform, which means whatever the Terraform CLI version you have installed in your respective desktop or server. So if that respective version is not present in the desktop or server, then it will not be going to provision or update or destroy your infrastructure. This means you are doing a version lock-in for your Terraform, but with tilde greater than sign, you are given the feasibility of allowing some varieties of versions. Next, we will input the required providers, which in our case is AWS, right? Let me give the required providers. So in my case it is AWS, and the source equals to, so this will be some value. Similarly, I need to give the version. Okay, version equals to some value in here. One important thing you need to remember is inside the required providers block, AWS is the argument. Inside that, with a map information inside it as per this example. Difference between the argument and block is, for argument you are going to have equals to, here the example is AWS, and for block you are going to have the flower braces only, not equals to. So these are very important notations you need to understand. Now we need to put the values of these providers. Before putting the values of these providers, we need to understand what is provider block. So let us go back to our PPT. So provider block, this is the heart of the Terraform. This block sits inside the Terraform CLI and also the respective endpoint, which is nothing but the respective cloud provider. This provider which you are going to download, using this you will be able to provision the infrastructure on respective cloud provider. Terraform relies on providers to interact with remote systems. Declare providers for Terraform to install providers and use them. Provider configurations belong to root module. So in Terraform, you are going to have something called root module, also a child module. So as a Terraform admin, I will first install the Terraform CLI. So this is my Terraform admin. This is the local from the local desktop. As a Terraform admin from my local desktop, I am installing the Terraform CLI. Whenever you run the Terraform init command, it will go ahead and download the respective provider, whatever you have defined, the source and the version. So as I showed in my example, the source and the version. So whatever you are showing in here, the source and the version from this Terraform registry to your local desktop, it will be downloading the respective provider. Once it is downloaded, so whenever you run the Terraform validate and then you write your own resource code, you define your resources, everything, and run the Terraform plan and then Terraform apply. These things will communicate with the AWS APIs in the AWS cloud, and then it is going to provision that respective resource like EC2 instance in our this example, or whatever you have defined in your Terraform configuration file. Similarly, if you want to destroy that resource, you want to execute the Terraform destroy command, this Terraform destroy command, and then it will call those respective APIs and then delete it. Who is calling it? It is the Terraform AWS provider. So between Terraform AWS, Terraform CLI, which is nothing but terraform.exe, and also the respective cloud provider or the remote system, the intermediate connection is the Terraform provider. So every resource type is implemented by a provider. So that's the reason it is called as the heart of Terraform. Without provider, there is no Terraform at all. Without providers, Terraform cannot manage any infrastructure. Providers are distributed separately from Terraform, and each provider has its own release cycles and version numbers. So Terraform version numbers are independent. Also, the Terraform provider numbers are different. Terraform registry is publicly available, which contains many Terraform providers for most major infra platforms. So let us just type in Google Terraform registry and let's go in here. From here, you can browse the providers. The providers and the modules as on today are given in here. As you can see in here, it is 1614 providers and 7424 modules, and it is counting. So don't worry about the modules. Root modules are where you define your providers, and child modules are where you reuse the code of whatever is defined inside the module. So if you browse these providers, you can see what all providers are there. Those you can see from here. From Terraform providers perspective, provider requirements is whatever you defined in the Terraform settings block, and then provider configuration, whatever you do in your provider configuration. Like here we are giving the profile as default, and the region which you are choosing is North Virginia, which is US East 1. And dependency log files. This is dependency log file, how it looks like. So this is the log.hcl, and if you browse it, it will be like this, where you will be getting the version and the provider name also you will be getting here, which is registry.terraform.io slash HashiCorp slash AWS. So these are the core concepts from Terraform providers perspective. So next comes required providers. So important concept here is, what is this name AWS? So here AWS is a local name of your provider. So whatever you want to provide the name, and that is called the local name of your provider. So local names are module specific and should be unique per module. So this is module specific and this is unique per module. Terraform configurations always refer to local name of provider outside required provider block. So you define the name as AWS. So whenever you are calling AWS inside the provider block, you call it as AWS. If you define it as infra in your required provider block, you need to define infra in your provider block. Recommended way of choosing local name is to use local name of that provider. For AWS provider, HashiCorp slash AWS, preferred local name is AWS. So let us go to registry.terraform.io, and in here let us browse these providers and go to AWS. And in here, if you go to use provider, you will get the recommended name as AWS and the source as HashiCorp slash AWS. So let us now go to our settings block.tf in Visual Studio. And so we got our source. So what is the source? Source is HashiCorp slash AWS. And the version is tilde greater than 3.0. Okay. Now let us understand about the source. So let us go back to our PPT. So source, it is the primary location where we can download the Terraform provider. So ideally, the source has three parts, which is HashiCorp slash AWS, which you can see, but that refers to its own public registry, which is registry.terraform.io. So as we saw here, I believe, yes, you can see here in the dependency log file, registry.terraform.io/hashicorp/AWS. So this is the source. So where this one, it is not taken on its own because this is from hashicorp.io it is getting it. So the source address consists of three parts delimited by slashes, as you can see in here. The registry.terraform.io slash hashicorp slash AWS, where registry.terraform.io is the host name, hashicorp is the namespace, and AWS is the type, where this registry name, which is optional as default, is going to be Terraform public registry. So there are types of Terraform providers which we are supposed to use. Here you can see that those are mentioned by provider batches. So we'll be having batches like official, verified, community, archived. So what is official? Official is nothing but which are owned and maintained by HashiCorp. So let us go there. So in here you can see this batch is given. So this is the official batch which can be used. Likewise, if you go to Google Cloud Platform, this is the official batch which can be used. Now, next is this verified batch. These are owned and maintained by third-party technology partners, and HashiCorp has verified the authenticity of the provider's publishers. So in here, if you go to verified, so these are the verified providers, and you can see the batch. Similarly, community providers are published to the Terraform registry by individual maintainers, groups of maintainers, or other members of the Terraform community. In here, if you click in here, you will get the community providers. So these are the community providers. Okay. And the last is archived batches. So archived providers are official or verified providers that are no longer maintained by HashiCorp or the community. Similarly, for modules, if they are verified or heavily provisioned, you can start using them. So let us go to this AWS provider, and from here you can click on the documentation and see end-to-end documentation of the respective provider. So in here, let us provide the provider blocks. We primarily provide the region. If it's a default profile, you really don't need to define it in providers block. So let me comment it as provider block. Okay, so and the provider being AWS, and primarily I'm giving the region as US East 1. Okay, so this is taking this. So what is this profile? Now in here, if you are given this as profile equals to default, so what is this profile? Now you have declared the Terraform block like this, which is nothing but the required version and providers. Also, you have defined the provider block, which is with region US East 1. So you are telling the provider what you are going to download, that go and contact and connect with AWS Cloud, which is the provider in here in the US East 1 regions API. And now if you check in here, here's something called provider authentication is there. Okay, and whenever you define the resource, the provider needs to provision the resource in the Terraform cloud. So for that purpose, it needs to authenticate to your AWS cloud with some credentials like the access key and the secret access key. So those credentials you can pass as static credentials like access key and secret access key. So for this reason, we configured the AWS CLI in our previous session and provided our secret access key. So now we can provide the profile as default, which would in turn take the default access key and secret access key. If you need any other profile, those needs to be configured likewise and mentioned in profile. Like if you are given some profile name as infra, if you are taking this profile, so you need to mention it. But if it's not, if you are taking the default profile, then you need not mention it. For default profile, this is not required and it is taken automatically. So resource blocks. This is the block where you create your resources and you define your resource information here. Each resource block describes one or more infrastructure objects like resource syntax, how the resource syntax should be there for your AWS resource, EC2 like EC2 instance or VPC or RDS something. Resource behavior, how Terraform handles resource declarations, provisioners. We can configure resource post creation action using these provisioners. If you see here, you can find an example of a simple resource. If you see the resource is the block type. The AWS instance is the block label. EC2 demo is also the block label. So they are the resource block type and resource block labels. So resource being block type and AWS instance and EC2 demo being the block labels. Okay. So these are the top level blocks. In addition to this, you can have blocks inside blocks, something like provisioner blocks or tags. Also, you may have a number of labels for your block. Like resource has two labels, right? As you can see in here, AWS instance and EC2 demo. Similarly, variables, which will be seen in our next sessions, variable is having just one label. Whatever you defined inside the blocks are called arguments. So this AMI, this is the argument name, and right side, this is the argument value. So in here, AWS instance is called the resource type and EC2 demo is called the resource local name. We also need to understand the syntax in naming conventions. So first is resource type. So resource type, it determines that the kind of infrastructure object it manages and what arguments and other attributes the resource supports. Next is resource local name, so which is EC2 demo in here. It is used to refer to this resource from elsewhere in the Terraform module but has no significance outside that module's scope. The resource type and name together serves as an identifier for a given resource and so must be unique within a module. Resource local name plays a key role in the entire Terraform. Next, meta arguments. Meta arguments can be used within a resource to change the behavior of resources. Resource arguments. This will be specific to resource type. Argument values can make use of expressions or other Terraform dynamic language features. The resource behaviors. So whenever you have defined your resource and do a Terraform apply, it is going to create a resource. So these many things can be done with your resource behaviors. So create resource. Create resources that exist in the Terraform configuration but are not associated with a real infrastructure object in the state. Destroy resources that exist in the state but no longer exist in the configuration. Update in place resources whose arguments have changed. Destroy and create resources whose arguments have changed but which cannot be updated in place due to remote API limitations. So all these things will play in action with Terraform state. So let's create our EC2 create.tf. So in here EC2 create.tf configuration file, and in here let's create the EC2 instance and the resource being, so we are going to define a resource of type AWS instance. So let me give this as so the resource being AWS underscore instance and the resource local name being my EC2 VM. Okay, here we have the resource block, resource type and the resource local name. Resource block, resource type, resource local name. And now the arguments supported inside that resource we are going to get here. So AMI, now I need to put the argument. I will be hard coding the argument right now, but in our next lectures we will be seeing how to how to go ahead without hard coding it. So right now let us log into our AWS console. So let me go to EC2 and in here let me go to launch instances and take the AMI ID from here. Okay, so this is the AMI ID. Now let me go to here and put the AMI ID and then the instance type as t2.micro, which is the free version. I can just close it here, but what I'm going to do is I'm going to install a sample web server by passing user data for this instance. User data, it would be like this, like I will be having one .sh file, and let me give the example, and in here I will be passing it as file $path, which you will be getting .module, close it. Then if the example.sh, which I might have created, but this one I'm not going to do like this. What I will be doing in here, I'll be providing this as provisioners. So we are directly going to put the information in here. So provisioners can be used to model specific actions on the local machine or on a remote machine in order to prepare servers or other infrastructure objects for service. This Terraform includes the concept of provisioners, knowing that there will always be certain behaviors that cannot be directly represented in the Terraform's declarative model. So this is actually not at all recommended. So in here, the first thing what we will be doing is, let me give the key name. So the key name in here, what I will be taking is Terraform. So let me put the .pem file in here. So I will be getting the terraform.pem file. Yes, this is the terraform.pem file. Let me just put it in here. So it is right now present in here. So this is the pem file. So the key name will be Terraform, right? Now provisioner, and this will be remotely executing it, right? And inline, what things I will be providing is, I will be updating my kernel sudo yum update -y, then comma, then sudo, I'll be installing my Apache web server, sudo yum install -y httpd. Okay, then I will be starting my Apache web server, sudo systemctl enable httpd. Okay, then sorry, I will be enabling it. After enabling only I can start it. Sudo systemctl start httpd. Okay, so till now we have installed and started our httpd services. Now what I will do, sudo echo, and in here header 1, welcome to infra experts app install, and then close it. Okay, then sudo t var www html index.html. So I will route it in here. Fine. I missed to give this in here. So this is fine. Next, I'll be making a directory with the name web server, mkdir var www html web server 1. Okay, then (169.254) we are done with this. Now, once we are done with this, we need to give the connection details also, or else it won't be able to connect. So the type SSH, user needs to be given, which is ec2-user. Then the private key needs to be given, which I have already created. And the host equals to self dot public underscore IP. Next, you need to give something called tags in your configuration file. So tags, my bad, this is the provisional block, right? So you can see it is ending in here, so I need to give it in here, tags. So this is the tag I will be providing. Now let's execute these commands with EC2 create, and this, let me execute it. Let me just save it. So let me just run it. So right now I'm in here, and let's run Terraform init. So it is having some issues with my this file, right? So what it is saying, invalid character on line 11. What's the issue in here? Yes. What's the issue? It should be in double quotes, right? So this should be fine right now. So let me run this again. So right now it is initializing, and once this initialization completes, we can go ahead with validating this. So you can check the log.hcl file, it will be creating in here right now, and the provider version will be shown in there, and that respective provider hashes will be kept in there for reference. So as I said, a log.hcl file is created in here. From here you can see the version, the provider version will be shown in here, and the respective provider hashes will be kept there for reference. So let us now run the second command, which is terraform validate. So terraform validate. So this, my configuration is valid. Now let me run terraform plan, which will be providing me the execution plan. So this is my execution plan, where you can see that it is taking the my local name as this, the AMI ID as this, and this as t2.micro. These will be provided once our EC2 instance is provided. The tag name is provided in here. Now let me run terraform apply. In here I can give it as auto approve. So what will it do? It will go ahead and create the EC2 instance without asking for the approval. It will show the execution plan, and immediately it will start providing the resource. So you can see it is not asking for me to validate whether everything is fine and whether it should proceed with the EC2 instance creation. So right now I'll pause the video until the EC2 instance is created. So the EC2 instance is created, and you can see in here that it, what all things we gave in here, sudo yum update. So it was updating this, and then it installed the Apache services, and then created the symlink, what all we provided in here. It started the Apache services and all. So let us now go to our EC2 instance console, and you can see that the status check is initializing. Let me just copy it and wait till the status check is done. So let me just copy it in here and paste it in here. Okay, so you can see it is showing welcome to Infra Experts Apache install. Okay, and then let me give here a web server 1. So you can see this is coming in here, and metadata.html. You can see here that the whatever values it is taking, it is showing in here. This architecture, account ID, availability zone, billing products, and all, a private IP, scan, public IP, everything, instance ID, everything is being shown in here. Okay, now let us go to our presentation. So we have done till our resource block. Next, Terraform state basics. If you remember what we saw earlier, whenever you have defined your resource and do a Terraform apply, it is going to create a resource. So create resource that exists in that configuration but are not associated with a real infrastructure object in the state. Destroy resources that exist in the state but no longer exist in the configuration. Update in place resource whose arguments have changed. Destroy and create resources whose arguments have changed but which cannot be updated in place due to remote API limitations. All these things will play in action with the Terraform state. So what is this Terraform state? Whatever we create, destroy, update everywhere, it is related to Terraform state. So Terraform state is nothing but the underlying database for the Terraform actions, whatever it is performing. So in here, if you see, as a Terraform admin from your local desktop, from Terraform CLI, using Terraform init, you downloaded your provider. So plan, and then you execute your Terraform validate, plan, and then apply. So whenever you run your Terraform apply, our infrastructure gets provisioned here, thus making your Terraform apply command successful. So for the first time you run your Terraform apply and your infrastructure gets successfully created, your Terraform state file will be created in your local working directory. Now, if we go to if you open this, you can see in here that the version is given, the Terraform version is given, the mode is managed, schema version, the AMI ID, the ARN, the associate public IP beta is true, the availability zone it is showing here, US East 1B, which was provided. So my EC2 instance is currently running US East 1B, like that. The key name which was taken as Terraform, and the instance type as t2.micro. So each and every details you will be getting in here. The public IP you can see in here. This is the public IP which it is taken, where we logged in and saw our static website getting created. So everything is fine. So the real infrastructure details will be maintained in the Terraform tf.state file, .tf state file. So this file is critical. If this file gets lost or gets corrupted, then it will be a big problem. So Terraform must store state about your managed infrastructure and configuration. This state is used by Terraform to map real world resources to your configuration, keep track of metadata, and to improve in performance of your large infrastructures. This state is stored by default in a local file named terraform.tf state, as we saw in there, but it can also be stored remotely, which works better in a team environment, in a project environment. So it can be stored like backend, like that it can store in there. So the primary purpose of Terraform state is to store bindings between objects in a remote system and resource instances declared in your configuration. So it acts as a mediator between your cloud environments and terraform.tf configuration files. When Terraform creates a remote object in response to a change of configuration, it will record the identity of that remote object against a particular resource instance and then potentially update or delete that object in response to future configuration changes. So these are the Terraform states. So the desired state, this is nothing but your terraform.tf configuration file. So in tf configuration file, you are stating what is the desire, what is your desire means what configuration you want. So that is the desired state, and the current state, this is nothing but whatever the resource you have created in your cloud environment. So that is the current state. Now let us go ahead and destroy our resource. So here we are, and in here we can destroy, we can give like this terraform plan hyphen destroy, which will show you the plan of your, the destroy plan of your configuration. So this is showing, as you can see, the destroy plan. Now if you want to destroy it, how will you destroy? You can just say terraform destroy, or similarly as apply, you can proceed with terraform destroy hyphen auto approve, which will be destroying your resource without stating, without asking your permission. So we will be concluding our session till here, and in our next session we will be seeing about the other parts, which are the variable blocks such as input variable blocks, output values blocks, and local values block and data resources block. So stay tuned. We will be meeting soon with our next lecture. Till then, please do like, share and subscribe. Thanks a lot for watching this session. Take care. Bye.